I'm Anil Kumar, sharing with you test questions on quadratic functions application. Here is question number 3 in this playlist. The question here is, at Bell Park, a landscaper wishes to plant a uniform border of tulips on the inside of a rectangular garden with dimensions 12 meter by 18 meter. The whole garden will look the best if the area of the tulip border is half the area of the garden. How wide should the inside border of the tulip be to 1 decimal place? That's the question for you. You can always pause the video, answer the question, and look into my suggestions. Let's go through it once again. So at Bell Park, landscaper wishes to plant a uniform border tulips on the inside of a rectangular garden. So we basically have, let's say, a rectangular garden. Let me sketch here. And the dimensions of rectangular garden are given as 12 by 18. So this is 12, that is 18. The whole garden will look best if the area of the tulip border, let's say that's the border. So tulips are being planted in this region, right? So that's the region for tulips. So they are on the inside of this rectangle, right? The whole garden will look the best if the area of the tulip border, that means this border, is half the area of the garden, which is the inside garden. Do you see that? That's the question. How wide should the inside border of tulip be to 1 decimal place? So this area, which is tulip area, should be half the area of inside portion. Let us say x is the width of the border. Now, so we'll have a square x by x here. In that case, inside garden length will be how much? 18 minus 2x, and the width will be 12 minus 2x. So this will be 12 minus 2x, correct? So that becomes the area of the inside garden. Do you see that? So this area, inside garden area, is equal to the area of the tulip garden. That is what the question is. So let's find the area of the tulip garden, which is total area minus inside area. Is it okay? So we have area of the tulip garden. Total area is 12 times 18. Okay, so we have 12 times 18, that's outside, minus inside area. Minus inside area is 18 minus 2x times 12 minus 2x, correct? Now that should be equal to inside area, which is 18 minus 2x times 12 minus 2x. Perfect. So that is how you get your equation. Now we need to expand and simplify this and then solve for x. There's only one variable here, so let's do that part. So 12 times 18 is equals to 216, so we get 216 minus 12 times 18 is 216, so again I write, so let me put in brackets, 12 times 18 is 216, 18 times 2 is 36, so minus 36x. Now I'll multiply by minus 2x, so we get minus 24x, and that gives me plus 4x square equals to, now this inside term is exactly same, so we can write the same thing here, basically 216. We can combine these two, right? 36 minus and minus 24, they get added up, so let's say 36 plus 24, with a negative sign we'll write 60. You write this as minus 60x plus 4x squared. Is it okay? So basically, I just combine these two terms, right? And as such, you can see that this area and this area is same, correct? Now I'll bring all these terms to the right side. Now this negative becomes positive and all this is same as this. So we could write 0 equals 2. So when I bring all this to this side, it becomes 2 times all this, which is 216 minus 60x plus 4x squared minus 216. Do you see that? So that is how we kind of get a simplified equation. Now if I open this up, 2 times 216 and minus 216, one of them gets cancelled, right? So let's open. So what we get here is, let's multiply and then we'll do it. So 216 times 2 is 2 times 6 is 12, 1, 3, 432 minus 120x plus, or what we could do is we could just divide by 2, but we'll do it later, plus 8x squared minus 216. Now that gives us 8x squared minus 120x, and this when you take away you get 216, right? So you get plus 216. So that becomes your equation which you need to solve for x. Now here you could simplify this. You can divide everything by 8. You can take 8 common. You get x squared minus, let's divide 120 by 8. 120 divided by 8 gives us 15. And 216 divided by 8 is 27. So 8 cannot be 0, but this factor could be 0. So that gives me that 0 equals to x squared minus 15x plus 27, correct? So that becomes the quadratic equation which you need to solve. It says you have to answer to one decimal place. We'll apply the quadratic formula to solve from here. So the quadratic formula is, let's write down, x equals to minus b plus minus square root of b square minus 4ac divided by 2a, correct? So that gives us x equals to minus b means 15 plus minus square root of 15 square minus 4 times a is 1, c is 27 square root divided by 2. That is 15 plus minus. Let's find the term inside the square root. So we have square root within brackets. Okay, brackets already there. Okay, so we have 15 square minus 4 times 27 bracket close equal to 10.81, right? So it is 10.81. Okay, let's write 6 for the time being and 2. Now that gives us 2 dimensions for x. Remember, x cannot be more than 6, right? So we know x should be less than 6, otherwise, because the width is only 12. So we have to take the x value which is less than 6, okay? So we'll do 15. If I do 15 plus 10, 25 divided by 2 is 12 point something, which is more. So one of them is not valid. So we'll do 15 minus 10.816 divided by 2. So 15 minus 10.816, and then we'll divide by 2 to give us the answer, which is this one is equal to 2.092. So x can be approximately to 2.1 and the units are meters. Correct? So it says, how wide should the inside border tulip be to one decimal place? So the width of this border should be 2.1 meters. So we get our answer that the width is 2.1 meters. Is that okay? So that is how you can actually solve this. The other answer which you get by adding them, dividing by 2, is more than 6, and therefore it is not a valid answer. Remember that part. I'm Anil Kumar. You can always share and subscribe my videos. Feel free to post questions, and all the best. Thank you.